So let's start with just the basics. We're going to talk about extreme values, extrema, or minima and maxima. And I know you know that term because we covered in algebra, we covered in pre-calc, so you've seen it in algebra too, enough to know what extrema is. So anytime a function reaches a high value, a maximum value, or a minimum value, that's an extrema. What we do here is go into a little bit more detail. And you'll see that there is a difference if, it's over an entire domain or if it's over an interval and so on. All right, so let's start talking about absolute extrema values, right? Absolute extrema means the absolute maximum value or the absolute minimum value. So the very highest value or the very lowest value. Now, one word that we need to focus on is this word value, right? The term value. What does that refer to? The X or the Y? Yeah. It's actually the Y. So when you hear the word value, it's talking about the Y value, right? So I could say, what is the location of the maximum? That's X. But when I say maximum value, that's the Y. And it's a very, very common mistake for students, all right? Okay, so the absolute maximum value on a domain, all right, is f of c. If and only if f of c is greater than all other values f of x. So all this is saying is, on a given domain, f of c is the maximum value if it's physically the highest y value that it attains. And the same with the minimum. F of c is the minimum value if f of c is the lowest value that the graph approaches vertically. All right, so let's take a look at this. Most of the time, 99% of the time, you're going to be given a domain over which to look for extrema. Because in calculus, all right, as opposed to like algebra 2, let's say, we don't look at the entire function over its whole domain. Calculus is very much looking at tiny little intervals, okay? So here it says, on the interval negative pi to pi, find the maximum and minimum values of these functions, okay? Now, this is the graph of sine of x, and we're given the graph from negative pi to pi. And what is this value here vertically? 1. So this is 1 and this is negative 1. So now, this is the maximum value. Now, here's how you're going to say this. You're going to say that the maximum, okay, it's all about the notation now. F of something. What's the x value there? The x value. Pi over 2. If it's pi from pi over 2. If it's pi from the middle to the end, then this is pi over 2. So f of pi over 2 is equal to 1. So that's the maximum. Here is the minimum. F of negative pi over 2 is equal to negative 1. So this is the notation that I want. Because this notation tells us everything. First of all, it's giving you the value, which is the y coordinate, 1, right? And it's also, at the same time, telling you where it's located at pi over 2. Yeah?
For our answers, when they're asking us for maximum and minimum, will there always be both?
No. No. There could be none, there could be 1, there could be 2 of 1. Okay? All right, so take a look at this next one, for example. This is a maximum, and we say f of 0 is equal to 1. Okay? And now look, here we have a minimum, and here we have a minimum. Now, very, very important point here. When we were given the interval, we were given a closed interval. When you're given a closed interval, you are allowed to also reference the endpoints. So the lowest, it reaches a low value, a minimum value here at the endpoint. If these were open parentheses, you wouldn't be able to reference that. But because it's a closed interval, because it's included, you can and you have to. So you say there is a minimum f of pi is equal to minus 1, and here there is a minimum f of negative pi is equal to minus 1. Okay? Did you have a question?
Yeah, so if it were parentheses, then what would the minimum be?
There, you would not specify a minimum, you would say none, you would just specify the maximum.
And also, if you have just like a horizontal line, is the maximum the same as the minimum? Or is there none?
There is none. That's just a constant function, yeah. Okay, so look at this one now. We need to find the absolute extrema. So when you hear the word extrema, you have to look for min and max of f of x equals x squared on each domain. Okay? All right. So here, yeah.
When it says f of x equals x squared, I'm confused what the x squared means.
That's the function. So here the function is graphed for you. It's a parabola, right?
Yeah.
So that's what it is. That's just a parabola. Okay, so if the domain were negative to positive infinity, where is there an absolute max? Is there an absolute max?
Yeah.
There is not an absolute max. Why not? Because this goes on forever. No matter how high you go, it's still going up forever. Because where is infinity? Really, we don't know. It could be, you would think you are at infinity, but then there might be another point afterwards. So there is no absolute max. There is, however, an absolute min here, and that's f of 0 equals 0.
But how does that make sense? Because isn't it going from negative infinity?
There's a minimum here because this is the lowest point vertically it reaches, and then it just goes back up. Okay? Now, the next one is from 0 to 2 inclusive, right? All right, because you're given, yeah.
Isn't 2 lower than that?
Well,
Oh, you mean like on the x?
right, 0 to 2. So basically, this is the graph that I'm looking at. Okay? All right, so from 0 to 2. Now that you have a closed interval, you're allowed to look at the endpoints and what happens in the middle. So let's talk about absolute maximum. What is the highest value, y value that this reaches? It's 4. So we say f of 2 is equal to 4. And the lowest is f of 0 equals 0.
So only on a closed interval you don't have to worry about if it's going to infinity?
Right, well, it's a closed interval. It
It's
stops.
only looking for 0.
Yes. Okay, next we have 0, open circle on 0 to infinity. There is definitely a maximum point, f of 2 equals 4, but there is no absolute minimum. So none.
Wait, why?
Because it's an open circle, you're not allowed to access that point. Okay? Next, 0 to 2, if they're both open, it's none for both.
So why wouldn't?
Why wouldn't? Because technically, what would have been the lowest point that this reaches here? But you're not allowed to access that point. And there is no other point for you to access because you don't know. Do you take 0.1? Do you take 0.001? You see what I mean?
Yeah, but I'm confused why when the brackets are around 0 to 2, when you get the f of 2 equals 4 and f of 0 equals 0, why wouldn't that be for the parentheses?
Because if it's a parenthesis, this is open. That point is, you can't touch it. It's off limits for you. All right, so there is a little disclaimer here. This example shows that a function may fail to have a maximum or a minimum value. This cannot happen with a continuous function on a finite closed interval. I'll come back to this at the end of this lesson. Okay, now, one of my favorite theorems ever.
You didn't say that anymore.
Okay.
You can at least pick one.
All right, my favorite theorem of today. Okay, my favorite theorem of today.
You have a different favorite theorem every day.
I have to say there are some coming up that definitely are my favorites.
It's like depending on like how you wake up. Like I'm kind of.
Oh,
It's
no,
like
no,
you just
no.
have like a bunch of friends and you go to like, oh, you're my best friend today. But then the next
Oh,
day-
no, not at all. They're like my children. I love them all equally. Okay, so, huh?
You wouldn't pick favorites if you look close.
No, you're right. That's why I said one of my favorites.
Favorites and still love them.
Okay, if f, so here it is. And you know, we've done this previously, right? These theorems have all these words and symbols and this and that. But really, we've done this before where we've read the theorem, we've dissected it, and then all of a sudden we go, well, yeah, I could have come up with that on my own. So let's do that here. If f is continuous on a closed interval AB, closed interval, and f is continuous, like that, right? Closed interval, f is continuous. Then f has both a maximum value and a minimum value on that interval. Well, duh, right? Because if you have a function on a closed interval, endpoint here, endpoint here, there's definitely going to be a point where it reaches the highest value ever. And there's definitely going to be a point where it reaches the lowest value ever. Okay? So that's the extreme value theorem. Now, how to find the absolute and maximum and minimum values? So 3 steps. Okay. Love this stuff. So first you have to find the critical points. Okay. What are critical points? Obviously, these are points where important things happen. Okay? Huh? Yes. Yes and no. Make sure the critical points are in the domain. All right, so here is a critical point. A critical point is a point in the interior of the domain where f prime is 0 or f prime does not exist. One more time. A point in the interior of a domain where f prime is 0 or it does not exist. So we find the critical points. We evaluate f of x at each critical point. Okay, and now most common mistakes students make, they leave out this part, and both endpoints. So once you find the critical point, you're going to have some critical points and you're going to have 2 endpoints. You have to find the value at all of those points. And then this part's easy. Largest value is the absolute max, smallest is the absolute min. So, where are we looking to find maximum and minimum? Critical points and endpoints. So, extreme values occur only at critical points and endpoints. So take a look here. Take a look at that first function. What is the value of the derivative here? What's another word for derivative? Slope. How much is the slope of, or the derivative at that point here? 0. Right? How about here? 0. So if this is a point where f prime is 0, is that a critical point? Yeah. So that's a critical point. So in this case, take a look at where the absolute max and absolute min happen, at a critical point. Okay? Yes, you see that? Yeah.
I'm confused.
Okay.
Where is the critical point?
Okay.
Is that where it touches, when it goes through the
Okay. A critical point is where the derivative is 0. Where is a derivative 0? No, the derivative, where you have a horizontal tangent. The tangent here is horizontal, f prime is 0. The tangent here, the slope of the tangent line here is 0. So it's got a horizontal tangent. It's got a derivative of 0. So where the derivative is 0, you've got a critical point, and that's where you have a minimum and a maximum here. In this case, this is a closed interval. Is there a point between A and B where there is a horizontal tangent? Is there? Is there a point where it looks like this? No. I'll tell you another way to figure out where there is a horizontal tangent. A horizontal tangent happens when the graph switches between increasing and decreasing. Look here. Increasing switches to decreasing, horizontal tangent. Decreasing switches to increasing, horizontal tangent. That never happens here, no horizontal tangent. So the absolute minimum and maximum happen at the critical point, at the end points. Okay? Yeah.
So the slope of the one on the left is 0 because it has doesn't have a slope right there because it's changing.
Yeah.
Okay.
It's the same when like a ball is going up, right? Positive velocity. And then when it comes down, it's negative velocity. And then there's a point in the middle where the velocity is 0, same situation. Isn't that cool?
All
right.
Be able to tell the difference between this one and one like this.
Which one?
Like
Well, that's what this section is about. So by the time we're done, you won. All right? Okay, so those were more examples, but let's go to a more practical example here. All right, so it says to use...
Yeah, they're supposed to be closed.
Oh, is it closed? I was going to check. What's going on? Why isn't it?
My eraser's not working on my side.
You know what? I had the highlighter selected and it never works. When... Yeah, it's funny. Okay. There we go. So is that how you have it? Okay. When it says use analytical methods, you're going to do this. Okay? It's really pretty straightforward. We find the critical points. How do we find the critical points? Take a derivative, set it equal to 0. So let's take a derivative. So find CP, critical point. Take derivative, set equal to 0. All right, so f prime of x is negative 2x plus 4, right? This is where your derivative skills are going to be of use. Now, we set this equal to 0. Okay, so you have to look at where f prime of x equals 0 or undefined. So it could be undefined when you have a fraction, let's say. We'll get to that. I'm getting a little ahead of myself. All right, f prime of x is equal to 0 means negative 2x plus 4 is equal to 0. So how much is x?
2.
Right. X equals 2 is a critical point. Now, you have to find f of x for the critical point and the what? And the endpoints. Yes. The endpoints are 0 to 3. 0 and 3. Yeah?
Sure.
Right? Okay. So, we're going to do f of 2, f of 0, f of 3.
Why?
We already found f of 0.
Huh?
We already found f of 0.
No, we set f prime of x equal to 0. So f of 2, remember, we're not going to plug it into the derivative. We're going to plug it into the original function. So f of 2 is negative 4, negative 2 squared, which is negative 4,
That original function.
plus 8 minus 5. Yeah. In original function, let me write that down.
Yeah,
Negative 1. Okay, f of 0, negative 5. F of 3, how much is f of 3?
-9 plus 12, 3, minus 5, -2.
Negative 2. Okay, now, these are your y values. Here, the y value is negative 1, and then the y value is negative 5, and then the y value is negative 2. So what's the highest of all of these points? Negative 1 is the highest, right? So this is your absolute max. So we would say f of 2 equals negative 1.
So the -5 is the absolute min.
Correct. This is your absolute min.
But what are the endpoints? Oh, never mind. I understand.
Yeah. So I have to say, the most common mistake is, like in this case, this was a bit simpler because we had one critical point. You can have 2 critical points, 3 critical points. Most common mistake I have seen is the student will check the critical points and then just stop there, absolute max, absolute min. They haven't checked the endpoint. Don't let that happen to you, okay? Yeah. Did you have a question before?
I answered it.
Oh, cool. Love those types of questions. Okay, while I answer this question, we're going to do the next one. So start figuring out f prime of x here. Oh my, that's a power. We're going to subtract 1 and da-da-da-da-da.
But what's -2? Is that just nothing?
Right, -2, it falls vertically between -5 and -1. So that's just the middle point.
Okay.
It's like the middle child. It gets neglected. I say that and I have 3 boys, but anywho, okay.
Wait, I'm confused that the endpoints were in the last one.
Huh?
0 and 3.
0 and 3 were.
It gives it to us.
It's the endpoints of the interval. Okay, so derivative here. 2 over 3, x to the 2 over 3 minus 1. Thank you. Okay. Yes, that's a cube root. So really, it's 2 over 3 x to the positive third. Yeah, which is really 2 over 3 cube root of x. Yes. So now, when you set this equal to 0, right, you would technically say the numerator equals 0, which doesn't make sense. That's why we say it's where the f prime equals 0 or it's undefined. So in this case, where the denominator would equal 0 is where this is undefined. At what value of x would this denominator be undefined?
0.
Or 0, which, yeah. So at x equals 0, the function would be undefined.
Why 0?
Because what happens if x was 0? You would have 2 over 0. Not cool.
Oh, that's true.
Okay.
Why wouldn't you put the 3 under
The 3 is a coefficient. It was 2 over 3 times. So the critical point is x equals 0. So now what we're going to do is we're going to find f of 0, f of -2, and f of what? 3.
Was 2 the critical point in x?
Yeah,
Like what we found critical point?
yeah,
Wait, I have a question.
yes.
Where did you? How is the critical point 0 though?
The critical point is either where f prime equals 0.
If that doesn't exist,
If that doesn't happen, then it's where f prime is undefined. In other words, where the denominator is 0. So, remember how f of x was given to us in that fancy little notation? Let's just write it in a better way that we can use. Okay, because that I know what that is exactly. And now if I plug in 0, it's cube root of 0, which is 0. Cube root of -2 squared, right? It's cube root of +4. And here I have cube root of 9. Okay. I don't need to know the decimal value of any of these. Okay? You don't need to know that. Can you tell right off the bat what's the smallest value here? 0 is the smallest value. Okay? So here we go. Yes.
Why don't you have the 2 anymore? In the numerator. Like why is it not a fraction?
This was f prime. We're plugging it into f. Okay? Now, so we know the smallest. Between these two, which one would be the biggest? Cube root of 4 or cube root of 9? Cube root of 9. Do you see how it's irrelevant what the actual decimal values are? We just have to compare them, okay? Again, calculus is about the big picture, okay? Isn't that cool? Now we're really having fun, I tell you. At least I am anyway. I could do this like all day. You would just say f of 0 equals 0. You would say absolute min, f of 0 equals 0, absolute max, f of 3, cube root of 9. Oh my gosh, e to the x, e to the negative x. What's f prime? E to the negative x times negative n. It's like you guys just took a test on this or something, right? Okay, so f prime of x is negative e to the negative x. E to the x is a special type of function. Okay? We try to find where f prime of x is equal to 0. Where is negative e to the negative x equal to 0? So how would we solve? So first of all, this would be e to the negative x equals 0 because we divide the negative on both sides. Normally, if you remember from algebra 2, the way we solve this is take the ln of both sides. Remember? So ln. So then we divided it out. Yeah. So ln and e vaporize one another. So negative x is ln of 0. What's ln of 0?
0.
ln of 1 is 0. What's ln of 0?
1. How would you know?
Undefined.
Undefined. It does not exist.
What is ln?
ln looks like this.
It's natural.
Look. I'm going to tell you how to do this in a variety of ways. Normally, we wouldn't really do this. ln looks like this. Okay? It never hits 0. So ln of 0 never works. Just know that. So it's one of those things. You're walking down the street, you see ln of 0 on a billboard, you just know undefined. Okay? Now, how else would you have known that? Our original problem, the original problem we had was this, right? Or e to the negative x equals 0. Now, remember what e to the negative x, e to the x looks like this. E to the negative x looks like this. In either case, is e to the x, is that function ever 0? It's never 0. So when you have e to the x, there is no way it could be 0. Here's another way you could look at it. You have a number raised to an exponent. Can you think of an exponent where a number to the power of an exponent would give you 0? No. So no matter how many, e to the 0 is 1. So no matter, see, like this, I just told you like 3 different ways to look at this. In either case, e to the x can never be 0. What does that mean?
Undefined.
There are no critical points. Yeah. No critical points.
So we just plug in the so we just do f of the endpoints, that's it?
Look at you guys, it's like you could teach this class, right? So no critical points, that means just check endpoints.
So negative 1 and 1.
Correct.
But for the problems that we did earlier, there's always going to be the 2, remember to give us plus 0 when we find. You potentially always have the 2 endpoints and a critical point. So we just saw that it's not guaranteed that you have a critical point, but you're definitely going to have the 2 endpoints. Okay. So please be careful here. Another common mistake, people just mess up with the negative sometimes because you're rushing. E to the negative 1, right? So that's e to the plus 1, which is e. And then here we have e to the negative 1 over e. Again, I don't care what the actual value is, okay? Between e and 1 over e, which one's going to be bigger? E is going to be bigger. So absolute max
f of minus 1 is equal to e. Absolute min f of 1 is 1 over e, not e to the minus 1. Man, I love this stuff. I really do.
We can't just write ops max equals c in the upright diagonal.
Yes.
Can you
Yes.
just do that and then at the end of it, like put